There's one situation that you did not have on your quiz that we did not talk about last class, is what happens if, when we're talking about end behavior, and we're still talking about end behavior here, what happens if your numerator has a larger degree? For example, if I talk about end behavior, that's a limit question. So many of you ask me, it's like, is this a limit question? It's like, yeah, like everything's a limit question, essentially. End behavior is a limit question. You're asking yourself, what is happening if I'm plugging in very large positive or very large negative values? Okay? Well, if I look at the top polynomial, 4x squared wins. If I look at the bottom polynomial, x wins. You only do this, guys, when you're plugging in infinities, when you look at the biggest degree in the leading coefficient. So maybe you ask on the homeworks, it's like, how do you get this answer? It's like, because I wasn't plugging in infinity for that question. You don't do this process if I'm plugging in 3. Okay? You just plug in 3. See what happens. You have a vertical asymptote. You look a little bit further. You got that? You got that? Okay, good. Are you like staring through me? So the end behavior of this polynomial will be determined by 4x squared over x. Well, when you divide those two, what do you get? 4x. Now, we have to be careful. You can't use a plus or minus anymore, because this rational function's end behavior is the exact same as this polynomial's end behavior. What is 4x's end behavior? Tell your neighbors. So it's weird when you're looking over there, you're like, oh, no, you're wrong. But it's like, no, you're right. It's just direction, right? Yeah. We are talking about a positive x to the odd. It is down and to the left, up and to the right, or as x approaches negative infinity, I'm going down and to the left. You can get this answer as well. You plugged in negative infinity into 4 times x, you get negative infinity. But like, whatever, if we know about polynomials, we're good. If you plug in positive infinity, you would get that end behavior that I'm going up and to the right. So we have end behavior that is infinities, like we're used to. We're used to polynomials to have infinity end behavior, or y's are infinity. That's just tricky because it's like there's more options for rational functions to be. Okay, this guy. If I were to look at the end behavior, I wouldn't care about the 7x cubed. I wouldn't care about the 1. I would care about the x to the 4th over the negative x squared. Divide those, what do you get? And then tell your neighbors, what's the end behavior? Good. You get negative x squared. Okay. This process is saying that this rational function's end behavior is the exact same as that polynomial's end behavior. That polynomial's end behavior is down and to the left, down and to the right, which means as x approaches negative infinity, I'm going down. That's this one. That's a negative infinity going down. And as x approaches positive infinity, we are also going down. So negative infinity in both x infinity directions. Got it? Do the last 4. Honestly, it takes longer to write the limit statements correctly than it does to figure this stuff out. I know, but do it. And make sure the X approaches and the value is underneath the LIM. You guys are sloppy. Your X arrow value ends up like bleeding over or slash under the F. We don't do that anymore. If you draw arrows, like, yeah, that's probably what you would do on notes, being like, I got it. Yo, I've seen this before. Do you do it like that because you're looking at it sideways?
Yeah.
Because you, okay.
Yeah.
Because you know that it's really like that.
Yeah.
Okay, but since you're looking at it sideways, you're drawing it that way. I was like, I'm worried, that's all. But we're good, okay. Sorry, that was just bad. Good. Nice. All right, let's check. If you're not done, whatever, you kind of are picking up what I'm putting down, right? X to the fifth over X squared, X cubed, positive X to the odds and behavior. If I plug in negative infinity, I get negative infinity. If I plug in positive infinity, I get positive infinity. This is negative 2x to the sixth. This is x squared, so that's x to the fourth times x. That's an x to the fifth, which gives me negative 2x end behavior, which is up and to the left, down and to the right. So to the left, I got positive. I think this would probably be the one that maybe people would get wrong. And then to the right, I got negative because I'm going down and to the right. Or another way to get this same answer, plug in infinity. Negative 2 times infinity, it would be negative infinity. The way to check. This is x to the 6 over x squared. That's x to the fourth. We're up and up. So we got positive infinity and positive infinity for both of them. This is negative 2x to the fifth, not negative 3x to the fifth, because you're dividing. And that's up and to the left, down and to the right. I'll just talk about going to positive infinity when you get down to the right. Cool. All right. So, not that bad. I feel like we could do more. Okay, let's do a little bit more. Okay, cool. Let's look at this guy. Tell me about the end behavior of this next guy. To do it on the right, you need space on the left. So just like right here. Tell me about the end behavior. Just gonna be like X, right? We are just gonna worry about X. Up and to the right, down and to the left. But it's like, okay, that means this function will, at the end, look like y equals x, is what I would think about. So I'm going to go ahead and look at this function. Look at what we see. This rational function, x squared plus 6x plus 7 over x plus 5, towards the end, positive infinity, negative infinity, looks like a line. The end behavior follows like y equals x. So I'm going to go ahead and graph y equals x. But something's wrong. It doesn't look like it's exactly y equals x, especially over here. The further I kind of get away from things, the further away this kind of is, it looks like it's off a little bit. It doesn't look just like it's going to be y equals x. So I want to do more analysis to really understand what my end behavior looks like. Yes, it will be similar to y equals x, but it's not exactly y equals x. It will be, you know, the similar end behavior. We'll get our infinities right, but in terms of exactly how it's going to travel, it won't exactly be there. So what are we going to do? We are going to actually divide. We are going to divide x plus 5 into x squared plus 6x plus 7. No, because your calculator can't help you. Now, do you guys know how to do long division? Well, let's remind ourselves how to do long division. Come up here and let's take 5, 6, 7, 8 and divide it by 3. Okay, so 3 divided by 5, 6, 7, 8. What do? You try to figure out how many times 3 fits into 5,000. And then you'll figure out what's left over, and then try to fit in 3 with what's left over, figure out what's left over from there. It's just a process. This is a numerical process that many students don't understand why it works, but it does. You're like, okay, I want to try to get rid of the 5. I'm going to put a 1 here. And then I multiply 3 times 1, and I get 3. When my cursor comes back, I'll do that. It's coming. Point what? Point something. Come on.
Above my paper. There you go.
It just like freezes and then it comes back. All right. So we find that 1,000 of these 3s goes into 5,000. Okay. So what we do though, the numerical process is like, okay, 1 times 3, and then we subtract. Why are we subtracting? We're finding out what's left over after having 1,000 3s. Okay, well, we got 2,000 left over. Well, in reality, we have 2,600. You guys don't care. The next step is 3 times what gives us 26. Well, the biggest number that goes into that is 8. 8 times 3 is 24. What you're actually doing is figuring out that like 1,800 3s is the biggest thing that goes into 5,600. We have a leftover 278, but what you care about is that what goes into 27, which is 3, and you do 9, and it's like, okay, well, I take care of that 2,700, but I have an 8 left over. Well, we can get 6 out of that 8. We have a remainder of 2. Now, what does that remainder of 2 mean? I still need 2 of these thirds more to get every part of the 5,678. If you use your calculator, You can see that 5, 6, 7, 8 divided by 3 is 1,892 and 2/3. Cool? Cool. Well, the same process works with polynomials. Now you know what the first thing's going to be, because you know it's like x squared divided by x. You know that you need x times x plus 5 to get rid of this x squared. Just like we're trying to figure out what number is the most that I could do to get rid of the first thing. So we start by putting an x right here, because we know x times x plus 5. And that's the next step you do, is you multiply these just like you did with numbers. You multiply these and you get x squared plus 5x. Now here's the key step, that if you guys are going to make a mistake, it's here. You need to subtract this entire thing. Not something that you have to worry about much with long division, because like you just subtract 24, it makes sense. You don't have to distribute a negative, but you have to distribute the negative so that you know, okay, I'm subtracting 5x from 6x. This is very important when you're subtracting negative. Giving you 1x and a plus 7. Just like you brought down the 7 and brought down the 8, we'll continue to bring stuff down. Now, just like we did here, as we try to get rid of the next thing that's left over, okay, I need to get rid of the x plus 7. I need 1 x plus 5. 1 times x plus 5 is x plus 5. We subtract those. We get a remainder of 2, which means we need 2 more x plus 5. Now, what we just found is that y equals x squared plus 6x plus 7 over x plus 5 equals x plus 1 plus 2 over x plus 5. 2x plus 5. Don't you dare sleep in this class. Okay. I didn't mean to hit you in the face. Yeah, sorry. Yeah. I aim for trick it. Yeah. Okay. You guys didn't even do it.
No,
So,
I'm listening. I understand.
All right. So, now, we know this rational function is the same as this summation. Tell me, as x approaches infinity, what happens to this part? It gets smaller and smaller and smaller and approaches 0. As x approaches infinity, this goes away. My function will not have x end behavior, but rather x plus 1 end behavior. What does that mean? What does that mean? Watch, guys. X plus 1. Does that fit with the rational function? Perfectly. Now watch this. Add 2 more x plus 5. You get the same thing because they're equal to each other. Pay attention. Linder. When you divide, you are just getting an equivalent form. It just looks different. This and this are the same. But if you're talking about end behavior, you're plugging in infinity. This goes to 0. This is what we call an equation of a slant asymptote, an equation of end behavior. So the answer is that my end behavior, my slant asymptote, is y equals x plus 1.
Do you not say the O short because that's like 0? That's just the equation.
Because that goes to 0. As x goes to infinity, we don't have to worry about it.
What do you think?
There is no horizontal asymptote. We have a slant asymptote. We have an asymptote that has a polynomial behavior. We have a y equals x plus 1 asymptote. Yeah, but it won't help you like you think it can. Yes, you can use decimals on the PSAT. Now, really quickly, if you're just dividing by x plus or minus a number, you can use synthetic division. Now, here's how you do synthetic division. X plus 5 is what you're dividing. You will write the roots. You flip the sign of the plus 5 to a minus 5. Why? It like allows you to do an addition instead of a subtraction while you're doing this process. I don't understand why they just didn't keep it as a positive 5 and you use subtraction like you would long division, but don't worry about it. You put your coefficients of what you're dividing into. Do you guys remember this? You bring down the 1, that's like the 1x. You multiply diagonally, you add going down. Why do we add instead of subtract? Because we flipped the 5 to a negative 5. If you kept it as positive 5, you could subtract and it works. Okay, divide diagonally, you get negative 5. Add, if you subtract it, anyway, you get a 1. Divide diagonally, you get another negative 5. Add, boom. What you have is your remainder followed by your numbers followed by your x's. This is another way of getting x plus 1 plus 2, x plus fifths. But as x approaches an infinity, the 2x plus fifths will go to 0. What we have is an end behavior that will mimic / be exactly the same as y equals x plus 1. We call it a slant asymptote. Yep.
You can only do that as synthetic division when it's just like that.
You can only do it with synthetic division if it's just x plus a number. So only x plus or minus a number. Got it? Okay. Let's just find a slant asymptote for this guy. You can't use synthetic division for this one. Okay. Heads up. You're all going to make a mistake, but the little note there on your notes hopefully is preventing you from making a mistake. What is the mistake I think you're all going to make? You're missing the x term. Now you could get this right if you don't put the x term, but a lot of you will not understand that you're missing it and will do things incorrectly. So if you are missing an amount of something, put that you have 0 of that something in to help with your long division. Ready, set, go. Do it. Jesus, I love Jesus. Jesus, I love Jesus. Jesus are great. Start with the 2x cubed. We need to get rid of the 2x cubed. Now, you actually can think about our end behavior. Oh, if I didn't care about this and if I didn't care about this, I get 2x cubed over x squared, which simplifies to be 2x. That's actually helping you find your leading term, your leading kind of value. It is telling you your end behavior is going to be similar to 2x, but we're going to find a very specific equation that will show us the ends of this rational function. Okay, multiply this by this. Write it down here. Okay, ready? Subtract all of this, which means you gotta distribute that minus. Good. After subtracting, we should get 5x squared, 12 x's, and 5. Got that? Now we try to get rid of the 5x squared, just like with numbers. Okay, well, I need a, what? No. Distribute the negative, Ira.
Oh, yeah. Wait, yeah.
You would need a 5. Good, but write it as a plus 5. Good. Plus 5 times x squared, 5x squared, plus 5 times negative x, negative 5x, plus 5 times negative 6 is negative 30. Subtract that quantity. Don't make mistakes. By not distributing the negative, you get 17 x's and 35. You guys get that? Okay, good. I got positive 17 x's plus 35. Now, you know what? I don't know if I might have made a mistake. But here's what I'm going to go ahead and say. I think that 2x cubed plus 3x squared plus 5 divided by x squared minus x minus 6 is equivalent to 2x plus 5 plus 17x plus 35 x squared minus x minus 6. I think those are the same. I can check by graphing.
Yeah.
Goodness gracious. All right, here's what the original graph looks like. Okay. I think if I add 17 x's plus 35, x squared minus x minus 6's, that this graph will be smack dab on top of my green graph. Ready, set, who was right, Mr. Messner or somebody else? Mr. Messner was right. So if you got negative 17 x's, if you got some other number besides 35, you were wrong, you made a mistake, you did not distribute the negative. I nailed it. Now, what happens as x approaches infinity, this goes to 0, we see that your function's end behavior will mimic / be exactly the same as not 2x's end behavior, but 2x plus 5's end behavior. So we have an equation for end behavior, and that's the purpose of this lesson. This is our slant asymptote, because this goes to 0. Asymptote. Great. Okay, let's look at this situation. I'm going to take this polynomial f of x, and I'm going to divide it by x plus 2. Now, really quickly, let's pretend this was like a free response question. And I asked you, hey, what are the locations of the vertical asymptotes for this rational function? Tell your neighbors, what would you say? Where's the location of the vertical asymptote? Yeah, right? It's obvious. Vertical asymptotes are where we get a 0 in the denominator. So everybody's saying x equals negative 2 is a vertical asymptote. You feel good about yourself, and you're like, okay, next question. I'm crushing this test. Dominating everything. 100, Mr. Messner, right here. Now I look at this question, I said, nope, you're wrong. Because watch this. Let's go ahead and use some synthetic division and divide. All right. What happens if I divide 2x cubed minus 9x squared minus 20x plus 12, I don't need the plus 12, by x plus 2. All right, do synthetic division is a great one to practice synthetic division. We practice long division. Practice synthetic division.
No, I'm going.
Great. I know.
Just by the number of the letter.
You multiply diagonally, you add going down.
Wait, how do you do this?
I showed you earlier, Ire. We flip the sign of the plus 2. You like find the root.
Oh, yeah.
You bring down the leading coefficient. You multiply diagonally. You add going down. -2 times +2 is -4. Add -13. -2 times -13, +26. Add +6. -2 times +6 is -12. Add 0. Okay, what is this telling me?
No remainder.
It fits into it perfectly. There's no remainder. It tells me that it's a factor. It tells me that this numerator can be written as the product of x plus 2 and 6 plus -13x's plus 2x squared. Let's try to show that all the different ways, and that's kind of what's going on up here. 2x cubed minus 9x squared minus 20x plus 12 over x plus 2 equals 2x squared minus 13x plus 6. We just got that result. Multiply both sides by x plus 2. That's what I put, +6. It's just my crazy stick. I'm sorry, okay? Right. Multiply both sides by x plus 2. And what you get is that the numerator, 2x cubed minus 9x squared minus 20x plus 12, and this is kind of what it's showing here, equals this times this. Now let's think about that. Your numerator divided by x plus 2 would have to be equal to this product divided by x plus 2. Oh, you thought x equals -2 was a vertical asymptote? You're wrong. What is it? It's a whole. Because it'll actually be a location of a 0 in the top and a 0 in the bottom. If you divide evenly, what you discover is that you actually have a factor. You could take something, if there's something that divides evenly into it, it's a factor of it. We could pull it out, and whatever's left over, boom, you got that. I never like to say always, okay? We never like to say always in math. What we like to understand is the situation that's present is that since we know dividing things evenly, we get that this product equals that. We get that x plus 2 is a factor of that. We could factor out the x plus 2. We have a 0 in the top and the bottom. We can answer questions. X plus 2 is a factor of s. This is true. The quotient is a factorable quadratic polynomial. Guess what? You'll be able to factor this as well into 2x, x, -6 and -1. And all of a sudden, you take a crazy polynomial, and it's actually the product of 3 different binomials. It's not actually that important for this class. It is important to say that it is a factor, and it's important to recognize that, oh, if it's a factor, then that's a 0 for the numerator as well.
Yep.
Okay. True. Let's see. Stella's not going to win.
I think I call that though.
No. The remainder is a non-zero constant. Yeah, there was no remainder, so this is false.
Okay.
The quotient is a factorable quadratic. Yep, I factored this thing into 3 different things. Okay. So let's go and figure this out. I got g of x. And I'm dividing it by give me the equation of the end behavior. Don't tell me what the end behavior is similar to. I want the exact equation of the end behavior for this rational. No, the remainder goes away if you plug in infinity. The equation of the end behavior is like the equation of your Slane asymptote. It's the rest of the stuff. The good stuff.
I like
All right.
yummy. Where are you going? Oh my God.
Don't forget we got 0x squared. Mike, you have to practice. Don't think that long division is going to like figure itself out when it comes to quiz time. Yo, the homework video is not that long. Don't do that. The homework video is not that long. But like Mr. Huffaker who made it knows how to do long division, okay? So he's going to do it faster than you. Don't copy down the answers. You got to practice doing long division. Why are you copying down? What? Why are you copying down? What? I'm erasing this. I'm erasing everything. You're not going to see what I do. You do it. Stop it. Do it. It's too much work, but it's not that hard. It's like, well, it's not busy work. It's work that must be done.
Wait, how can those functions be called P?
So now this is y equals.
No, they're both P though.
I'm dividing by p.
Yeah, but it has to be the same thing, right?
Just don't worry. Just do the one on the left. Let's not worry about the one on the right either. I'm trying to get out of this question or something. You happy? You happy now? I did. Did you get a remainder of 6x minus 5? Okay. Now, hold on. What do you have? Explain the meaning of what you just did. Explain the meaning of what you just did.
I divided it and got the slant.
No. Close. I like our thought. So we started out now this rational function is crazy. 6x to the fourth plus 5x cubed plus 2x minus 5. Okay. We see the end behavior is similar to 2x squared. We see that it's up and to the left and up and to the right, so we get a similar by looking at the leading terms. But after doing a full-on analysis of what's going on when we divide, we get 2x squared plus 3x, close, plus 2. what we have is an equation for end behavior. It is actually not considered a slant asymptote because this is curved, but it is an equation for the end behavior. And reminder, if you include the remainder, what you are actually doing is just having the equivalent form of what you started with. This is going to lie exactly on top of the black guy. Okay?
I didn't say that wasn't easy.
Gotcha.
That wasn't easy.
We're good. Don't worry about it. All right. Now, here is a question that shows up on your test. I don't care. I don't care. The last question. The last question of page 23. We'll find out. Probably that we're going to do that. Okay. Come straight out of your test. There's an easy way to do this question. There's a hard way to do this question. Yes, this question. You didn't email me. I'm going to talk to you. Okay, figure it out. Go, figure it out. Hey, this is a test question. You didn't study.
Are we allowed to divide?
Hey, you didn't email me. You didn't email me.
I didn't email.
Did you text me?
No. Okay.
You didn't even text me.
No, I didn't. I got going with another.
You know what she said? She's like, my coach is going to email you. I'm like, your coach? Give me a break.
You know what I said?
What?
It's not my fault.
So I should mark her late. All right. This is all going on YouTube. It's great. Okay.
How much fun is it to embarrass your own kids sometimes?
It's great. What's the answer? No.
What?
You couldn't figure out the easy way?
I haven't done it yet. Can you divide the top and bottom by 2?
You guys are going hard, and you shouldn't go hard.
Go crazy. Go stupid. I want to go.
They just ask you for the degree and leading coefficient of G.
What is it?
3x plus I don't care. 3x plus I don't care. When I divide my biggest degree term, I'm going to get 2x. Yeah, is there a plus 3 after it? Sure. Sorry, 3x squared. Thank you. So the degree is x squared. The leading coefficient is 3. We could have also figured that out by taking that and dividing it by 2x plus 3, but it just takes longer to do. Not much longer, though. So if it's a slant asymptote, then you understand that that function divided by g will give us 2x plus 3 plus a remainder. Yeah. Okay. So if you want, you could multiply both sides by g and divide both sides by 2x plus 3, and you'd get that g equals 6x cubed minus 4x plus 20 over 2x plus 3. If you'd like to then divide to get g, you can, but let's pay attention to the division. 2x plus 3 into 6, okay, I need a 3x squared. Boom, I just got that same answer, 3x squared. I don't care about the rest of it, but it's just like 2x will be my leading term when I divide the 2. So if I don't care about the rest of the stuff and I don't care about the rest of the stuff, I know this has to be 3x squared. because 6x cubed divided by 3x squared gives me 2x.
Oh, yeah.
Okay. Later.